Okay. Hello from my side. I'm Panagiotis Famelis. We will go through the first walkthrough of P4-based demo. Basically, we're going to do what yours described before with the device, service, and policy, and see how we can actually do that thing in a minute, basically. That is for today. Tomorrow we are going to go a little bit. Today it's mostly a walkthrough. Tomorrow we will get our hand a little more dirty, because we will go over how we can create scripts that communicate with the components of TerraFlow. And also, we will, in the second session, we will see some P4-based stuff, a little introduction into P4 in-band-based telemetry, and all that. So, first of all, if there are any questions, please ask. And if for some reason I'm going too fast, please tell me so. Okay, so before we start, I hope that you all have the VM. If not, there are some USBs here. And first of all, let's go and make sure that we have the correct network configuration before we begin, before we start the VM. So in network, I'm using VirtualBox. I hope that we are all on the same software, so we can follow the steps. So on File, let's do it again. File Preferences, we go on Network, and then we create a new network. I already have one. It will be by default named NAT network. Let me do that. Oh, no. And in the options, just put 10.0.2.0 here, /24, support DHCP, and then on port forwarding, you should copy this configuration. So basically what we are doing here is that we are forwarding the port 80 of the VM to the port 8080 of the host of our laptops, basically for HTTP, so that we can access the web UI. And also we are forwarding the VM port 22 to host port 2200, basically to be able to connect through SSH. So I hope that it's clear. If something is not easy to read, please ask. Should I move on? Yeah? Okay. So then we go to settings. On network, we select the NAT network here. And on the second drop-down list, we select the network that was created. If it was just one, the default, it will be named NAT network. With that, we are ready to start the VM. So that will start here. Until it starts, let me go back to the presentation. So basically, first of all, we're going to see how we can install TerraFlow SDN and what are the parameters that we can define here, and what we are going to use for our specific installation. Let's wait a couple of minutes for this to come up. It came up. So here, the username is TerraFlow, and the password is TFS123. And we're in. Also, it's good to, as we have said, if you have installed Visual Code and the SSH plugin, in the remote explorer here, first of all, in the SSH, select Settings to open the SSH config file, and put this. So basically what we're saying here is that to find the VM, when we SSH to localhost, we will use port 2020.00. It's better. Okay. And the user TerraFlow. That is so that we can actually connect to the VM through the VS Code. Everything clear? Okay. Yeah. So now we open the remote connection, connect to host, remote SSH, and we select localhost. Most probably it will be first in the list. And that opens a window, localhost. It will request the password. It is TFS123. And we should have connected to the VM. So if we TFS123. So we should see here our home directory. Everything okay? Okay. Okay. Also, if you want to just SSH, you can do an SSH -p 2020.00 teraflow at localhost. And this should have access to the VM. If you don't want to use VS Code. Okay, so first of all, Teraflow, in order to be able to deploy Teraflow, we have this, we say mydeploy.sh script. Basically, it's a list of parameters that we can define on what we want to install, if we want all the components or some of the components, etc. And also what to do with the build, if we want to rebuild the components or just use the ones that we have already built. Basically, if we go here, we can see in the controller, we have this mydeploy.sh. Do that. The most important stuff that we can actually use is begin here. So here we have many different lists of components. First of all, we have the basic components that need to be deployed, so context, device, path computation, service, etc. Then we want to uncomment the second one, which is monitoring. It will be already uncommented. Then we want to also uncomment the policy one. So basically, we're deploying the basic stuff, monitoring, and policy. The rest, for now, we're not going to use them. Then here we have this, which is important somewhat, which says if we want to rebuild the Teraflow components or use the ones that are already built. For now, we will leave it as nothing, so that it will be rebuilt. And then we have the various databases. Here, I suggest not to change anything other than maybe this one. It is good if you want to redeploy Teraflow, if you are doing some experiments, etc., in my experience, to always redeploy the database unless you have something that you want to have saved. So I would suggest to go here on the CRDB redeploy yes, also to the NATS redeploy yes, also to the QDB redeploy yes. This is already done in your VM. However, this is some instructions if you want to do some stuff by yourself. Yes? Yes, about the SSH or the, okay. Okay, is the VM up? Then it should be running. It says maybe, it says that, okay. So in that case, we are ready to go on. Is this okay from behind? Is it large enough to read? Okay, great. So, yes, okay. So if we do an IPA pipe less, we should get here an IP address. This one. Yes. TFS 123, and the user is Teraflow. IP, IPA, pipe less. Sorry, but I'm not sure how I can make that larger. Yeah. Sorry. This one. 10, 0, 2, 4. Yeah, but you have the same. I'm not sure why it doesn't work. So only you manage to do it, nobody else. Ah, okay. I didn't knew that. So you have to delete this network and redo it? Okay, please do so. I wasn't aware of this bug. Okay, you created just now. Did you also create it right now? Okay, can you try and delete it and redo it, the network? Sorry? Yeah, just to check that the VM IP, it is where? No. You mean this one? This one here? No. This should be 0. But this here, the guest IP, should be the IP address of your VM. Is it different? Okay. Can you also check that? So if you do an IP, let me do that here. IPA pipeless, you should get this IP here. 10.0.2.4. Maybe it will be different in your case. Yes. Yeah. So make sure that IP a pipe less. Okay. Yeah. Good. So this IP here, the N of the interface NP0S3, this one here, 10.0.2.4, this should be the one that we put here in the guest IP. So you also managed to do it? Okay. Yeah. Great. This one here. Yes? Great. You? Great. What? There was, it is a link to that directory. But maybe the link didn't, I don't know. I didn't push the link, maybe. In any case, this is the place where you should find this. Yeah. Okay. Great. So this here is a file that describes our various objects that we will have. So basically, if we go, okay, we have context and topology. These are just default things we will just use as is. And then we have this devices section. What we do here is we define each device. How do we do that? We first of all give it a name. So SW1 is a name. Then we give some timeout so that we know if there is disconnection from the switch, etc. And then we define some information on where to find this device. So first of all, what you should do is here in device switch one underscore name, you should put, not name, IP address, sorry. You should put the IP address we also put, sorry about that. We also put of the VM, basically. So if we have a different IP address before, this should not be 2.4, it should be, for example, 2.15 or something like that. Okay? This basically what it does. Sorry. What it does is that says that you will find software 1 on this IP address, which is the host, the AVM, in this port, which is the 5001. Then it also describes where you will find the P4 artifacts you may have. And then it creates this device and it creates the endpoint of the device. So here we have how we define a P4 device for Teraflow. This is the information a P4 device needs. Okay? And then we consolidate all this on some specific connect rules, which basically link to the above information. So I want you all to go over to this device switch IP address and put the correct IP address. Okay? This will be on line 63. But also it will be on line 103. We just put again here the same. Again, if your VM is not on 2.4, just put the correct IP address. And also we will do it for switch number 3 and switch number 4. Have we all done that? Yes, no? Are we all on the same page now? Okay. Great. So after we have defined here the various devices, we go on and define the links. So basically, we define a link from switch 1, port 1, to switch 2, port 1, a link from switch 2, port 1, switch 1, port 1. Basically, it's a duplex link. It goes both ways. That's why we're defining 2 times. And then the rest of the links. Of course, you can use all these if you want to create bigger topologies or different topologies. You can use this script here as a basis to create, to adapt to your topology. And then we have the service, what you also said before. So what we're defining here is that we want a service, we just name it. This is just a name. It could be any name. But we want from endpoint switch 1, 3 to endpoint switch 4, 3. And that's how we define this service and the endpoint IDs of this service. And then just a collection of all this information we had before. So basically the device, the links, and the services. So again, it is important so that the experiment will run. Make sure that we have all these IP addresses of the 4 switches to the correct IP address of the VM. By now, most probably Teraflow should be installed. Is somebody waiting? No, okay. So if we do a kubectl get pods minus n TFS, basically what that does is that it will return the status of the various pods in the namespace of TFS. We should get the various components and hopefully running. Yes? Okay, that means that we have a running installation of Teraflow. Okay. So now we can proceed and see, yes, okay. Let's now go to the NG SDN tutorial. If we want an absolute path, that would be this. Here we can run a make mn -cli. This would bring us to the mininet CLI. And if we run nodes, we should get the 4 nodes, the 5 nodes, 6. So client, server, switch 1, switch 2, switch 3, switch 4. Is it true? Okay. Great. So these are the nodes that are available. If we now do a client ping server, it should return nothing because currently the devices are not on board on the Teraflow SDN controller. The service is not set, so this should not communicate. This is expected behavior. So now open another terminal here. You do this by clicking this plus thing. And now we're going to run over these commands, which basically are 5 scripts that we will use for this experiment. So the first one, setup, just copies the artifacts, the compiled program we already have in our repository of before to the correct place. This one basically bootstraps the devices. So based on what Yoro said before, it runs the first layer. So it puts the devices on the Teraflow SDN, but does not enter. It enters the specific program, but does not enter any specific rules. And then this create service will create the service. So we'll have this connectivity service from one endpoint to the other. So let's try and go until 3. So first of all, we run setup. Okay, so we want to run this command. Okay. We've all run the setup. The first one. Ignore this one. The first one. This one. Okay. Should I proceed? Not yet. Just run the setup. The setup, it's okay? Okay. So now let's run the second one. Sorry, I was just showing the. Great. Everything okay? It says passed. Yes, I want to show this. Everything okay? Great. So now if we go to our browser and we do localhost 8080 web UI. Unfortunately, I cannot. We just select, and it shows here. I cannot show it. Nice graphical representation, but this can be fixed. But most importantly, if we go here on the device, we have the 4 devices. It says here disabled because I have not started the automation component, but it's okay, it's not disabled. It runs. And here in links, we also have the links that we have defined in the object topology. Yes? Should I proceed? Yes. It's localhost. Let me write it here. Localhost 8080/WebUI. And it should be like this. And here we select the context and topology. And we should have here devices and links. Yes? Great. Okay. If we go back to this other terminal we had, again we cannot ping. And that is normal because we still haven't created the service. So let's go where we ran the previous scripts, and now we run the second one. So src test hackfest run test 02 create service. Have we run that? Okay, so first of all, here in service, we have a service that says, if we push this little icon here, it says that we have a service from this endpoint, so switch 1, port 3, to switch 4, port 3, and this is the path, so switch 1, switch 2, switch 4. So basically, if we see the topology I showed you before, it goes the upper path, like this. So basically, if we want to show a graphical representation of what we've done, it's basically we first of all created, we defined the service, we send a service request. This shows through WebUI, but we did it through a script. And path computations was called so that it could compute a path between these. And that is why we also had 2 links, one going that way and one going the other way. And then the service took upon itself to request through the SBI specific rules to be set on these devices. So instead of going through each one of the devices, we just define the service, and this takes the work of defining all the necessary rules. And we can also test that, if we go back to Mininet, by trying to ping. And now it should ping. Yes? Sorry, what? Okay, great. Now, again, if we go... Yes, yes. Yorgo. Of course. Sorry, a little bit high because I can... Yes. Uh, to, to be truthful, I have not touched the slice component, so I cannot tell you a lot about this. What I can tell you is that we will see that tomorrow a little bit. Service works, as we said before, about devices that have different plugins for different protocols. Also, service has different service handlers. And different service handlers, first of all, communicate with different protocols on the SBI, but also they can handle different things. So, for example, you can have a service handler for P4. You can have two service handlers for P4 in case you have different kind of things you want to do. But about the slice, I'm not really familiar with it. Okay, so let's just, for now, delete the slice. So run this one. And now we're going to see how we can have some monitoring on this stuff. So we can go to what you described before about the policy stuff. Yorgo, do you want me to? So let's continue. So monitoring. We're going to use some scripts that are in Hackfest/probe. We will see how to get there. But before that, let's just open another terminal, first of all. Go to controller. So we should be in this folder here. And do a source TFS runtime environment. Vars. What that does is basically it brings in the environmental variables the variables of TerraFlow. So basically where each component is, what IP it has, what port it connects to, etc. Okay? Okay. Then we're going to go to SRC, tests, Hackfest 3, probe TFS. Okay. Okay. So first of all, here there are some scripts. We want first of all to run deploy.sh. Huh? Ooh. Disregard what I'm doing now. Sorry about that. Sorry about that. Give me a minute. Uh, 8080, localhost 8080, web UI. Just give me a minute. Sorry about that. Let's go to that. To that place. So basically, controller SRC tests Hackfest 3 probe TFS. We are there. Okay. Now I'm going to request you to run this command because for some reason it is missing, and that is my fault. I'm sorry. Before probe TFS target. So basically, just if you can run this. So cp -r, then controller SRC tests P4 now, not Hackfest 3, probe TFS target. Yes, space dot, yes. So are we okay? Great. For some reason I have deleted this. I don't know why. Are we okay? Are we here? Do you want me to make it larger? It's this here. This is the command. I hope that it is visible to anyone. The last one. Yes, yes. I will update the repo. It shouldn't. This shouldn't happen. This should be there. I will upload the repo. I mean, this should be there. Okay. Great. So now here we have various scripts. We want to run this deploy.sh. So basically, we want to run this command. It didn't work? What does it say? Did you forget the space, this one here? Disregard the C here. Space dot, yes. Okay, great. So just deploy. And then run this dot connect to mininet. It's already. No, this is not deploy TFS. This is just copies the scripts for monitoring to the Docker container. It's not deploy TFS. Okay. So now we should have another terminal, which is in the Docker container that we're running Mininet. Yes? Great. So basically, we have now two scripts. The first one is TFS agent. The second one is TFS ping. TFS agent is the script that basically connects to monitoring and also to context. And what it does is that it listens to events from context. And in case there is a service registration, it creates a KPI for that service. And then it listens for TFS ping, so for the other script. And when TFS ping, which basically what does it pings through this service, and it collects latency. So it sends latency to TFS agent, and that TFS agent creates the KPI for the monitoring. So we're going to run here TFS agent, and we should hope that it says something like that. So that I connected to the monitoring, I'm waiting for new connection, and I connected to the context service. What it does? You're asking what it does? Basically, what it does is that it instantiates gRPC clients, and it connects to the monitoring, to the context, and listens for events from there. And also it connects to the monitoring, and when it has an event, it will register a KPI there. We will also see that tomorrow in the first hacking session. We will recreate these scripts in Python and see how we can actually build around that. So for now, we just want to see that this is running, don't stop it, and it is connected to context, etc. Yes? So now let's go to the first terminal, not this one, where we ran before the setup, the bootstrap, the create service, etc. And now we just want to create the service again. So run this, run the create service script again in another terminal. Okay. It failed. Have you deleted it before? Can you run the third one, the delete service? We had done this before. Maybe you skipped it. Run test 03, delete service. It passed. Okay, now create service again. Okay. Yes. What does that what it does? This script? The TFS agent. This one. Okay. So we are now trying to insert monitoring into our experiment. And we have two scripts, TFS agent and TFS ping. TFS ping basically pings from client to server, takes the latency, and sends it to TFS agent. And TFS agent, first of all, listens to context about service registration, creates KPIs on that, for that service, and also takes the latency measurement from TFS ping and creates KPIs on that. So, sorry. Okay. Give me. Yes, yes, yes. Give me just a moment because I'm not sure what is happening here. Okay, to the ones that run the create service, does your TFS agent show this, or it shows something else here? Just this, nothing else. Policy rule action recalculate path. So basically, we're asking that when the latency goes over 10,000, we want to recalculate the path. And what we wanted to see, if that was able to run, is that when we add some delay in the path, so let's say that, for example, the original service went from this path, we add some delay by ourselves. Yes, sorry. So basically, we have established the red path, and then we add some delay, and we want to test that. First of all, monitoring would check that this latency went over the threshold, and then this would trigger a path recalculation, which would trigger a service request to delete the old rules and install new ones. Unfortunately, currently we cannot show that to you. However, tomorrow the first session was dedicated basically on that. And the idea for tomorrow is to, here we have latency, and the idea for tomorrow is to try and have another KPI. So how could we build a script that, like the one that we're using, but we're building it from scratch, that basically will communicate with context and receive the events, communicate with monitoring and create the KPIs, and then we're thinking maybe other than latency, we can easily calculate loss ratio. So basically moving average ratio, we're calculating, and then we are saying that if loss ratio goes over 5%, then we want to switch paths. This is what we will do tomorrow, the first session. Just a nudge, eh? Okay. We can do now. Yes. Yes, now it also creates the KPIs, you see? It creates the KPIs correctly. Okay, it worked. If somebody has time to see it. Well, the problem was with the nuts. We didn't create the port correctly. And then we needed to clean up and create the topology again.
Essentially what happened, at least it's the first guess, we need to investigate a bit more, but seems that when we were deploying, we were destroying the previous deployment of NAT, the cockroach, and the QuestDB. The problem seems to be that when deploying, in some cases, NAT reports that it is ready, but it is still not ready. And then when you interrogate, for instance, the service, well, or NAT, or maybe Kubernetes, that's one of the things we need to investigate. And might be that maybe NAT was not actually ready. We were trying to connect, we were being rejected, and we were trying to do the rest of the steps. So it was breaking the whole thing. What we did was to hard code the NAT port, just in case, redeploy Teraflow without redeploying the databases on the NAT, so keeping the previous one in a way that they are ready. The only thing we were doing is to clean up the internal tables of the cockroach and the QuestDB, just to have a clean setup. And then when you redeploy, given that NAT then is ready, you connect properly, and you can get the events and everything works smooth. Seems a problem of synchronization during the deployment. We are going maybe too fast for NATS, and NATS is not, I mean, as I say, it's reporting it's ready, but it's really not actually ready. We need to investigate. Maybe just a simple click in a key place resolves the issue. Something like that.
We know what to do tomorrow.
Yes. If somebody wants to create the issue and address it, we will be very happy.
By the way, I never recall this happening while we were trying to hack it.
No.
Never.
But it happened to me during the last month, preparing demonstrations, preparing experiments, whatever. It worked pretty fine.
It also could be.
Times and once open, it failed. And then after, I mean.
And when you're presenting.
Trying, it gets hard. And now it's good to know that
Yes.
depending on the way to deploy, it populates or not this specific attribute, and then we can try to fix it, and we get additional insight.
Yes.
I didn't have till now, but the problem during the missing value in the secret.
Yes. So what we have here is actually what you said before. In Grafana, we have a dashboard that shows us the KPI, the latency we have. So let me just do a little thing here. So you can see it gets here. And we can then add some delay, basically. And we will see that. Let's add a lot of delay. Okay, here we can see in the service, we can see the path so that we know where to add the delay, and we can see that it goes through switch 2. So here we will go on switch 2, Ethernet 2, let's say. And in Grafana, we should see it spiked, because now we have a lot of delay. And similarly, we could. Was it? Yeah.
All the points now that you get, the latest measurements are over 100 milliseconds.
So now, if we go here on gRPC, we have the policy. We will also go over this tomorrow, just to show you now. We're just going to make sure that we have here the correct So we're going to get the context ID from here. And the service ID. And how much is it now? Yeah, it's around a lot. Yeah. No, this is microseconds, so it is 100 or 100. So yeah. And then we run the add policy script. Sorry, yeah. I will go over this, what I'm doing now, tomorrow, but now we normally you should see it go down again because it changed path. It may take a little bit of time. Yes. You cannot yet see it because it's out of the picture, but basically you saw that it changed path here. And in here, now it says switch 2, which is the old path. If we refresh, we see that it went through switch 3. So basically, and also now, for example, if we remove this delay from here, from switch 2, the old path, and we add it on the other one, so we add it on switch 3, yes, we should again see that it spikes because we added a delay, but then after some time, it should again change paths. Hopefully. Yeah. So again, it changed paths because now we added the delay on the switch 3 path. So again, here it says switch 3. If we reload, it says switch 2. So this was the demo I wanted to show you, and this was how I wanted to go over the steps so that you can also do it. We will go over this tomorrow in the first interactive session. Thank you.